Hello and welcome to Documentary for Sleep, the quiet place where the day finally loosens its hold, where the noise of everything you had to carry begins to fade, and where the mind is allowed to drift somewhere vast and slow and impossibly far away. Tonight, we are going to travel further than we have ever gone before, not across an ocean, not beneath the ice, not into the depths of the earth, but outward, past the stars, past the galaxies, past everything we have ever named, all the way to the edge of what can be seen at all. Because there is an edge. Even in a universe that may go on forever, there is a boundary to what we are able to witness, a limit sewn into the fabric of reality itself, beyond which no light has ever reached us and perhaps never will. It is not a wall you could touch. It is not a fence or a shoreline or a cliff. It is something stranger and quieter than that. It is the edge of the observable universe, and tonight we are going to journey all the way to it, and then, gently, we are going to look past it, into the darkness we can only imagine. But before we set out, before we leave the warmth of the world behind, I would love to know, where are you listening from tonight? Somewhere in a city, perhaps, with the glow of streetlights washing out the stars, or somewhere quiet, out beyond the towns, where the night sky still spills open above you like something spilled from a jar. Maybe you can see stars right now through your window. Maybe you cannot. But I can promise you this: every one of those points of light is closer to you than the place we are about to visit, unimaginably closer. If this kind of slow, quiet wandering is the sort of thing that helps your mind unwind at the end of the day, I would be deeply grateful if you would like this video or subscribe to the channel. It helps this small, peaceful corner of the night find its way to other people who might be lying awake too, looking for somewhere gentle to rest their thoughts. And that is all this is meant to be, a place to rest. So make yourself comfortable now. Let your shoulders soften. Let your breathing slow. There is nothing you need to do and nowhere you need to be. Just follow me outward, away from the earth, away from the sun, away from everything familiar, into the deep and the dark, toward a border that has been waiting there since the beginning of time. Let us begin with a simple question, one that sounds almost childlike until you sit with it for a while. How far can we see? On a clear night, with your own eyes, you can see a surprising distance: the moon, 250,000 miles away; the planets, wandering points of light, tens or hundreds of millions of miles distant; the stars, scattered across the sky, some of them hundreds or thousands of light years away, their light having left them long before you were born. And if the night is truly dark, and your eyes are patient, you might catch a faint smudge in the constellation of Andromeda, a soft blur that is not a star at all, but an entire galaxy, 1 trillion suns bound together, 2.5 million light years away. The light entering your eye from that smudge began its journey before our species existed, when the first humans had not yet learned to walk upright. That is already a distance so vast that the mind cannot truly hold it, and yet it is nothing. It is the first step out the front door. Beyond Andromeda lie other galaxies, and beyond them clusters of galaxies, and beyond those superclusters, and vast empty voids, and filaments of light strung across the darkness like dew on a spider's web. The deeper we look, the more we see, and the further away it becomes, until at last we reach a point where seeing simply stops, a point where the universe, as far as our instruments are concerned, comes to an end. This is what we mean by the observable universe. It is not the whole universe. It is only the part we are able to see, the sphere of space from which light has had enough time to reach us since the beginning. Everything within it is, in principle, visible. Everything beyond it is hidden, sealed away, not by distance alone, but by time and by the very rules that govern how light moves through space. To understand why this edge exists, you have to understand two things, and they are both beautifully simple, even if what they imply is anything but. The first is that light does not travel instantly. It is fast, almost unimaginably fast, nearly 300,000 kilometers every second. fast enough to circle the Earth 7 times in the span of a single heartbeat. But it is not infinitely fast. It takes time to cross a distance. When you look at the sun, you are not seeing the sun as it is now, but as it was 8 minutes ago, because that is how long its light took to reach you. When you look at a star 1,000 light years away, you are seeing it as it was 1,000 years ago. To look out into space is always, unavoidably, to look back into time. The further away something is, the deeper into the past you are seeing. The second thing is that the universe has not existed forever. It had a beginning. Roughly 13.8 billion years ago, everything we can see, all the matter and energy that would one day become stars and planets and galaxies and you, was compressed into a state of unimaginable heat and density, and then it began to expand. We call that beginning the Big Bang, though it was not really a bang, and not really an explosion in the way we might picture. It was the beginning of space itself, the beginning of time itself, the first moment of everything. Now, put those two ideas together, and the edge begins to reveal itself. If light travels at a fixed speed, and if the universe has only existed for a finite amount of time, then light can only have traveled a finite distance since the beginning. There simply has not been enough time for light from the most distant regions to reach us yet. Somewhere out there, at a certain distance, we arrive at the light that has taken the entire age of the universe to get here. That is the furthest we can possibly see. Any further, and the light would need to have traveled for longer than the universe has existed, which is impossible. It has not arrived. It may never arrive. And so, at that distance, our vision ends. This boundary has a name. Scientists call it the cosmic horizon or the particle horizon, and it surrounds us on all sides, a perfect sphere with you at its very center. Not because you are special, and not because the Earth is special, but because this is simply how it works. Wherever you stand in the universe, you find yourself at the center of your own sphere of visibility, your own bubble of the seeable, bounded on every side by the same fundamental limit. An astronomer on a planet in a distant galaxy would find themselves at the center of their own horizon too, seeing a different sphere, overlapping with ours but not identical, reaching out into regions we can never glimpse. There is something quietly profound in that image. Every conscious being anywhere in the cosmos, if such beings exist, sits at the heart of their own observable universe, each one convinced, if they did not know better, that they occupy the middle of everything. And in a sense, each of them does. Not the middle of the universe, but the middle of what they can know of it. But here is where the story takes a turn, where it becomes stranger and more beautiful than the simple picture suggests. Because if you were to guess how far away that edge is, you might reason like this. The universe is 13.8 billion years old. Light travels 1 light year per year. So the edge must be about 13.8 billion light years away. It is a sensible guess. It is also wrong. The true edge of the observable universe lies not 13.8 billion light years away, but roughly 46 billion light years away, in every direction, more than 3 times further than the simple answer would suggest. How can that be? How can we see something that is 46 billion light years away, if its light has only had 13.8 billion years to travel? The answer lies in one of the most extraordinary facts about our universe, a fact so strange that it took humanity until the 20th century to even begin to grasp it. The universe is not static. It is not a fixed stage on which the galaxies move. The stage itself is growing. Space, the very emptiness between things, is stretching, expanding, carrying the galaxies apart from one another like raisins in a rising loaf of bread. And that expansion changes everything about how we understand distance and light and the edge of all we can see. But we will come to that. For now, let it settle in your mind, this idea of a horizon that surrounds you, silent and invisible, in every direction, above your ceiling, below your floor, past the walls of whatever room you are resting in, past the curve of the earth, past the sun and the stars. There is a boundary drawn around your existence by the speed of light and the age of time. And beyond it, waiting in a darkness we cannot pierce, lies a universe we will never see. Let us drift a little closer to that boundary now, and try to understand the strange and gentle force that pushes it ever further away. Imagine, for a moment, that you are standing in the middle of a vast field at night, and that the field is slowly, imperceptibly growing. Not that you are walking across it, but that the ground itself is stretching, every patch of grass drifting away from every other patch, the whole field swelling outward in every direction at once. If you planted 2 flags in that field and watched them over a very long time, you would see them slowly separate, not because either flag was moving through the grass, but because new grass was appearing between them, the space itself unfolding, pushing them apart. This is, as closely as words can capture it, what space is doing. It is expanding, not into anything, for there is no outside for it to expand into, but simply growing larger within itself, every region of it swelling away from every other region. The galaxies are like those flags. They are not, for the most part, flying through space away from us. They are being carried apart by the expansion of space itself, drifting further and further as the emptiness between them grows. We did not always know this. For most of human history, the heavens were assumed to be eternal and unchanging, a fixed and permanent backdrop against which the small dramas of earthly life played out. It was not until the early 20th century that we began to suspect otherwise. Astronomers, peering at distant galaxies, noticed something curious about their light. The light was reddened, not because the galaxies were red, but because the wavelengths of their light had been stretched, drawn out toward the red end of the spectrum, in a way that grew more pronounced the further away the galaxy was. This stretching is called redshift, and it is one of the great signatures of the expanding universe. As space itself expands, the light traveling through it is stretched along with it, its waves pulled longer and longer, shifting toward red, and then toward infrared, and then toward wavelengths so long and faint that they can barely be detected at all. The further light has traveled, the more space has stretched beneath it, and the more its light has been reddened by the journey. By measuring that redshift, astronomers could measure how fast the galaxies were receding, and what they found astonished them. The more distant a galaxy was, the faster it was moving away. The universe was not sitting still. It was flying apart in every direction, expanding, growing, evolving through time. And if it is expanding now, then in the past it must have been smaller. Wind the clock backward, and the galaxies rush together, the space between them shrinking, the universe growing hotter and denser, until at last, 13.8 billion years ago, everything converges toward that single, unimaginable beginning. The expansion is the echo of the Big Bang, still unfolding, still carrying the universe outward, even now, even in the space of the room where you rest. Now here is what this expansion means for the edge we are traveling toward. When light left the most distant regions we can see, those regions were much closer to us than they are today. The light set out across a smaller universe. But during the billions of years it spent traveling toward us, space itself kept expanding, stretching the distance the light had already crossed, and pushing its point of origin ever further away. By the time that light finally arrives at your eye, the galaxy that emitted it has been carried off to a distance far greater than the light ever actually traveled. The light took 13 billion years to reach us, but the source of that light now sits 46 billion light-years away, swept outward by the relentless growth of space. This is why the observable universe is so much larger than its age would suggest. We are not seeing a sphere 13.8 billion light-years across. We are seeing a sphere whose edge now rests some 46 billion light-years away in every direction, a bubble 93 billion light-years wide, filled with perhaps 2 trillion galaxies, each one a swirling city of stars, each one home to worlds we will never visit and skies we will never see. And the expansion has a further, stranger consequence, one that sits at the very heart of tonight's mystery. If space itself can stretch, and if it stretches everywhere at once, then the distance between 2 very far apart regions can grow faster than the distance between 2 nearby regions. The further apart two things are, the more space lies between them, and the more space there is to expand, and so the faster they rush apart. Beyond a certain distance, the space between us and a distant galaxy expands so quickly that the galaxy is effectively receding faster than the speed of light. That may sound impossible. We are often told that nothing can travel faster than light, and that is true for anything moving through space. But this is different. The galaxy is not moving through space at all. It is space itself that is expanding, carrying the galaxy along, and there is no rule that limits how fast space can grow. The cosmic speed limit applies to objects, not to the stretching of the emptiness between them. And so, out beyond a certain distance, there are galaxies flying away from us faster than any light could ever cross the widening gulf. Their light, cast in our direction, is like a swimmer trying to reach a shore that is receding faster than they can swim. It will never arrive. Those galaxies lie forever beyond our reach, hidden, not because their light is too faint, but because the space between us is growing too fast for their light to ever close the distance. Rest with that for a moment. Somewhere out there, right now, there are galaxies whose light will never touch us, no matter how long we wait, no matter how powerful our instruments become. They are not hidden by clouds or dust or distance in any ordinary sense. They are hidden by the geometry of a growing universe, sealed away behind a horizon woven from the expansion of space itself. And every day, as the universe continues to grow, a few more slip quietly across that boundary and vanish from our sight forever. We will return to that quiet vanishing later, for it holds one of the loneliest and most beautiful truths about the fate of everything. But first, we must travel all the way to the edge we can see and discover the strange and glowing wall that waits for us there, the oldest light in all creation, the very first thing the universe ever revealed. When you travel outward toward the edge of the observable universe, you are traveling backward through time. Each step further into space is a step deeper into the past. Near galaxies show us the recent universe. Distant galaxies show us the young universe, still forming, still crackling with the fire of new stars. And if you keep going, further and further, deeper and deeper into time, you eventually reach a moment so early, so close to the very beginning, that there were no galaxies at all, no stars, no planets, nothing but a vast glowing fog of raw matter and light, filling all of space, hotter than the heart of any star. This is where our vision ends, not at a wall of stone, but at a wall of light, and it is one of the most extraordinary things in all of science that we can see it at all. To understand it, we have to imagine what the universe was like in its infancy. In the first few 100,000 years after the beginning, everything was unimaginably hot and dense, so hot that atoms could not exist. The universe was filled with a searing plasma, a soup of free electrons and bare atomic nuclei, all crashing and jostling in a sea of radiation. And in that state, the universe was opaque. Light could not travel freely through it. Every time a particle of light tried to move, it collided almost immediately with a free electron and scattered off in a new direction, like sunlight lost in thick fog. The early universe glowed, but it glowed like the inside of a cloud, a blinding, formless brightness in which no ray could travel far before being scattered again. For nearly 400,000 years, the universe stayed like this, a glowing fog with no clear sky, no darkness, no room for light to run free. And then, as the universe expanded, it cooled. Slowly, the searing heat began to fade, and at a certain point, when the temperature dropped low enough, something quiet and momentous happened. The free electrons, which had been racing through the plasma, finally slowed enough to be captured by the atomic nuclei. They settled into orbits. They joined together, and for the first time, whole, neutral atoms came into being, mostly hydrogen and helium, the first true atoms in the history of everything. And when that happened, the fog lifted. With the free electrons now bound up inside atoms, there was suddenly nothing left to scatter the light. The radiation that had been trapped, bouncing endlessly for 400,000 years, was set free all at once. In an instant, across all of space, the universe became transparent. Light could finally travel in a straight line, uninterrupted, for as long as it liked, and it has been traveling ever since. That first freed light is still with us today. It has been crossing space for 13.8 billion years, stretched and cooled by the expansion of the universe, until its once blinding glow has been drawn out into faint microwaves, a whisper of radiation filling all of space, coming at us from every direction at once. We call it the cosmic microwave background, and it is the oldest light in the universe, the earliest thing we can ever see. It is the glow of the infant cosmos, the moment the fog lifted, preserved and carried across all of time to arrive, gently, in the present. When you look at the cosmic microwave background, you are looking at the edge of the observable universe, not a physical edge, but the furthest and earliest thing our eyes or instruments can reach. It is often called the surface of last scattering, because it marks the last place the ancient light bounced before it was set free to travel to us. Beyond it, deeper in time, the universe is opaque. We cannot see past the fog. The wall of light is the limit of our sight, a glowing shell that surrounds us on all sides, marking the boundary of the seeable. There is something almost tender about it, if you let yourself feel it. This faint radiation, so cold now that it hovers just a few degrees above absolute zero, was once the fire of creation itself. It filled a universe with no stars, no worlds, no witnesses, and it has been falling toward us, patiently, across an ocean of time so wide that our whole planet, our sun, our galaxy, all of human history, are barely a ripple within it. When you tune an old television to an empty channel and see that faint static hiss, a tiny fraction of that snow is not from the earth or the sky, or any earthly source. It is the cosmic microwave background, the echo of the beginning, whispering in the static, the universe's first light, still arriving, still here, in the quiet of your own room. But this wall of light also marks a threshold, a place beyond which our ordinary tools of vision fail entirely. For everything we have discussed so far, the galaxies, the redshift, the expansion, has depended on light to carry the information to us. And light cannot show us what came before the fog lifted. It cannot pierce those first 400,000 years. When we look at the cosmic microwave background, we are looking at a curtain, and behind that curtain lies the true infancy of the universe, hidden from our eyes. And yet, the story does not end at the curtain, because even though light cannot reach us from before that moment, the universe still existed then, and we can reason our way backward, following the physics, tracing the story into the darkness beyond the wall of light. What we find there is a realm even stranger, even more remote, and it deepens the mystery of the edge rather than resolving it. Before the fog lifted, before the atoms formed, the universe was a plasma, glowing and opaque. But go back even further, into the first few minutes, and the universe was hot enough to forge the very nuclei of atoms, cooking hydrogen into helium in a brief and furious window of nuclear fire that lasted only minutes and then was over. Go back further still, into the first seconds, and even those nuclei could not hold together. The universe was a churning sea of the most fundamental particles, quarks and electrons and their kin, so densely packed and so violently hot that matter as we know it could not exist. And go back further than that, into the very first fraction of a second, and we reach the edge not just of what we can see, but of what we understand. For in those first unimaginable instants, the universe was so hot and so dense that our theories begin to break down. The laws of physics that work so well in the world we know, the rules that govern stars and atoms and the falling of an apple, cease to give clear answers. We reach a frontier not of space but of knowledge, a place where the questions outrun the answers, where the very beginning of everything hides behind a veil we have not yet learned to lift. So the edge of the observable universe is really two edges at once. There is the edge in space, the horizon, 46 billion light-years away, beyond which the light has not had time to reach us. And there is the edge in time, the wall of light, the surface of last scattering, beyond which the universe is opaque to our sight. Both of them surround us. Both of them mark the limits of the knowable, and both of them hint at vastly more lying just beyond, a universe of which we can see only a thin and glowing shell. Let us pause here, at the wall of light, and consider something that is easy to overlook, but is quietly astonishing. The cosmic microwave background comes at us from every direction. Look up, look down, look toward any point on the sky, and you will find it there. The same faint glow, the same ancient temperature, remarkably uniform across the whole of the heavens. And this uniformity is itself a kind of miracle, one that troubled scientists deeply when they first understood it. For here is the puzzle. When we look at the wall of light in one direction, and then at the wall of light in the exact opposite direction, we are looking at two regions of the early universe that are separated by the full width of the observable sphere, more than 90 billion light-years apart today. Those two regions have never been in contact. Light from one could never have reached the other in the entire history of the universe. They have no shared past, no way to have communicated, no reason to resemble one another at all, and yet they do. They glow at almost precisely the same temperature, matched to within a tiny fraction of a degree. It is as though two people on opposite sides of the earth, who had never met and never spoken, were found to be humming the exact same tune, note for note. How could that be? The answer that scientists have proposed is one of the boldest ideas in all of cosmology, and it reaches back to the very first sliver of a second after the beginning. The idea is called inflation, and it suggests that in that first fleeting instant, the universe underwent a burst of expansion so sudden and so violent that it dwarfs anything that came after. In less time than it takes to blink, in less time than almost any interval the human mind can conceive, the universe is thought to have doubled in size again and again and again, ballooning outward at a staggering rate, growing from something smaller than an atom to something larger than a grapefruit, and then far larger still, all in the merest fraction of a heartbeat. If that happened, it would solve the puzzle. Before inflation, the regions we now see on opposite sides of the sky would have been tiny and close together, near enough to touch, near enough to reach the same temperature and settle into the same conditions, and then inflation would have flung them apart, stretching that small, uniform patch into the vast observable universe we see today, carrying its uniformity with it across the sky. The strange sameness of the wall of light would be a fingerprint of that first violent expansion, a memory of a time when everything we can see was small enough to be intimate. Inflation remains, in some ways, a theory still being tested, still being refined, still holding secrets we have not fully uncovered. But it does something remarkable to our picture of the edge, because if inflation truly happened, then the universe extends vastly, perhaps unimaginably, beyond the horizon we can see. That first burst of expansion would have pushed most of the universe so far away, so fast, that its light will never, ever reach us. The observable universe, for all its 93 billion light-year span, would be only a small bubble within a far greater whole, a single visible grain within a beach, whose true size we cannot measure and may never know. And so we arrive, gently, at one of the deepest questions we can ask. If the universe is so much larger than what we can see, then what lies out there, beyond the edge, in all that darkness we can never reach? Let us drift toward that question now, slowly, the way you might approach the edge of a cliff in fog, feeling your way, knowing that at some point the ground simply ends and the unknown begins. The edge of the observable universe is not an edge of the universe. This is one of the hardest things to hold in the mind, and one of the most important. When we speak of the observable universe, we are speaking only of what we can see, the sphere of space from which light has had time to reach us. But the universe itself almost certainly continues far beyond that sphere, stretching onward into regions whose light has not arrived and never will. The horizon is a limit of our vision, not a limit of reality. Cross it, if you somehow could, and you would not fall off the edge of anything. You would simply find more universe, more galaxies, more stars, more darkness, and a new horizon, drawn around that new position, just as far away as ever. Think of standing on a ship in the middle of the ocean. All around you, the sea meets the sky in a perfect circle, the horizon, beyond which you cannot see. But that horizon is not the edge of the ocean. Sail toward it, and it retreats. Reach the place where it seemed to be, and you find only more ocean and a horizon still circling you, always the same distance away. The horizon is not a feature of the sea. It is a feature of your vantage point, a limit imposed by the curve of the world and the height of your eyes. The cosmic horizon is much the same. It is not a feature of the universe. It is a feature of when and where you happen to be looking from. So the natural question becomes, how much more is out there? How far does the universe extend beyond the edge of what we can see? And here we reach the honest and humbling answer at the heart of tonight's journey. We do not know. We cannot know. Not fully, not with certainty, because the information simply cannot reach us. The unobservable universe is, by its very nature, hidden from every instrument we could ever build. We can reason about it. We can make educated guesses, but we can never look directly upon it. It is sealed away, not by accident, but by the fundamental structure of space and time. Still, we are not entirely in the dark. We can look at the part of the universe we can see and ask whether it offers any clues about the part we cannot. And when we do, we find something suggestive. The observable universe appears, on the largest scales, to be remarkably uniform. Wherever we look, in whatever direction, we find roughly the same thing, the same kinds of galaxies, the same web of clusters and voids, the same average density of matter, the same faint glow of ancient light. There is no special direction, no privileged place, no sign that we are near any kind of boundary or center. The universe looks the same, everywhere we can see, which suggests, though it cannot prove, that it goes on looking the same well beyond the edge, more of the same, stretching outward into the dark. This principle, that the universe is broadly uniform and looks the same from every vantage point, is one of the guiding ideas of cosmology. It carries a certain quiet humility within it. It says that we are not at the center of anything, that our corner of the cosmos is not special, that whatever is true here is likely true everywhere. And if that is so, then the universe beyond our horizon is probably not some strange and alien realm, but simply more of the vast, star-strewn sea we already know, continuing on and on beyond the reach of our sight. But how far does it continue? Is it finite, a vast but bounded space, curving back on itself somehow, so that in principle you could travel far enough to return to where you began? Or is it infinite, endless, stretching without limit in every direction, containing an infinity of galaxies, an infinity of stars, an infinity of worlds? This is one of the great open questions, and it turns on something subtle, the shape of space itself. Space, it turns out, can be curved. This is one of the strangest and most beautiful discoveries of the last century, that the emptiness we move through is not a fixed and rigid backdrop, but a flexible thing, able to bend and warp and curve, shaped by the matter and energy within it. Near a massive object like a star, space curves inward, and that curvature is what we feel as gravity. But space can also be curved on the very largest scales, the whole universe gently bending in one direction or another, and the way it curves determines whether the universe is finite or infinite. If space curves back on itself, like the surface of an enormous sphere, then the universe would be finite, though without any edge or boundary, much as the surface of the Earth is finite, yet has no edge you could fall off. Travel far enough in a straight line, and you would eventually arrive back where you started, having circled the whole of the cosmos. But if space is flat, or curves the other way, then the universe would be infinite, extending without end, a space so vast that the word vast fails entirely, containing not merely a great many galaxies, but a truly endless number of them. When scientists measure the curvature of space, using the faint patterns in the cosmic microwave background and the arrangement of distant galaxies, they find something remarkable. As far as we can tell, space is flat, not curved into a sphere, not curved into a saddle, but flat, to the very limits of our ability to measure. And a flat universe, if it is flat everywhere, would be infinite, endless, without boundary or center or edge of any kind. Let that thought rest in you for a moment, in the quiet. If the universe is infinite, then everything you can imagine and everything you cannot exists somewhere within it, an infinity of stars, an infinity of worlds. And here is a thought that has haunted and delighted people since they first understood it. In an infinite universe, with matter arranged in only so many possible ways, there may be, somewhere out beyond the edge of our sight, other regions that resemble our own, other galaxies like the Milky Way, other planets like the Earth, perhaps unimaginably far away, other people living out other lives, in rooms much like the one you are resting in now, listening perhaps to some quiet voice describe the edge of a universe they too can only partly see. We cannot know whether that is true. It lives forever beyond our horizon, in the unobservable dark. But it is not forbidden by anything we understand, and there is a strange comfort in it. This idea that the universe might be so large that nothing is truly unique, that every possibility, however faint, finds a home somewhere in the endless reaches of space. Of course, we must be honest. We do not know that the universe is infinite. Our measurements tell us that space is flat as far as we can measure, but a very large sphere also looks flat when you can only see a small piece of it, just as the Earth looks flat to someone standing in an open field. The universe could be finite, but so enormous that the small portion we can observe appears perfectly flat, its curvature too gentle to detect. We are like a tiny insect on the surface of a colossal ball, unable to tell whether the ground beneath us curves at all. The true shape and size of the universe beyond our horizon remains one of the deepest mysteries there is, and it may remain so forever, sealed away by the very limits we have been exploring. And this brings us back to the loneliness that lives at the edge of everything, the quiet truth we set aside earlier and must now return to, because the horizon is not fixed. It is changing, and the direction of that change is one of the most poignant discoveries in all of science. For a long time, scientists assumed that the expansion of the universe must be slowing down. It made sense. Every galaxy pulls on every other galaxy through gravity, and all that pulling should act like a brake, gradually slowing the outward rush, perhaps one day halting it altogether, perhaps even reversing it, drawing everything back together in a final collapse. That was the expectation. That was what the equations seemed to suggest. And so, in the closing years of the 20th century, astronomers set out to measure exactly how much the expansion was slowing, by observing distant exploding stars whose brightness could reveal how the expansion had changed over cosmic time. What they found overturned everything. The expansion was not slowing down. It was speeding up. The galaxies were not merely drifting apart, they were accelerating apart, flying away from one another faster and faster with each passing eon. Something was pushing the universe outward, overwhelming the inward pull of gravity, driving the cosmos toward an ever quicker expansion, and no one knew what it was. We still do not fully know. We have given it a name, dark energy. But the name is little more than a label for our ignorance, a placeholder for a mystery we have not solved. Dark energy appears to be a property of empty space itself, a faint, repulsive pressure woven into the vacuum, so weak in any small region that it is utterly undetectable, but so pervasive, filling all of the vast emptiness of the cosmos, that on the largest scales it dominates everything, pushing the universe apart with a force that grows as the universe grows. It makes up, by our best reckoning, the great majority of all the energy in the universe. far more than all the stars and galaxies and matter combined. And yet we can only see it by its effect, this quiet, relentless acceleration of everything away from everything else. And the acceleration has a consequence, a slow and inevitable one, that reshapes the very meaning of the horizon. For as the expansion speeds up, the boundary beyond which galaxies recede faster than light draws inward. More and more of the universe is crossing over into that unreachable realm. Galaxies that we can see today, whose light is reaching us now, are being carried across the horizon, their light stretched and dimmed and redshifted toward oblivion, until one by one they fade from our sight, not because they are dying, but because the space between us is expanding too fast for their light to ever again reach us. They are not vanishing. They are simply being sealed away, drifting beyond the edge of the seeable, into a darkness from which nothing returns. There are, in truth, two horizons that surround us, and it is worth taking a gentle moment to tell them apart, for they mean very different things. The first is the one we have spoken of most, the particle horizon, the boundary marking the furthest we can see, the edge of everything whose light has had time to reach us since the beginning. That horizon grows with time, slowly, as the universe ages and light from ever more distant regions has time to arrive. In that sense, our window on the cosmos has been widening throughout history, revealing a little more with each passing age. But there is a second horizon, and it works in the opposite way. It is called the cosmic event horizon, and it marks not the edge of what we can see, but the edge of what we can ever reach or ever affect, and the edge of what can ever reach or affect us. It is the boundary beyond which the accelerating expansion has become so overwhelming that no signal, no light, no influence of any kind could ever cross the gulf between us. And because of dark energy, because of that relentless acceleration, this horizon is not growing. It is shrinking, closing in, drawing tighter around us as the eons pass. Imagine the difference this way. The particle horizon is like the furthest place from which a letter has ever arrived at your door. The event horizon is like the furthest place to which you could still send a letter and have it ever arrive. In a static universe, those would be much the same, but in an accelerating universe, they come apart. We can still see galaxies whose light left them long ago, galaxies now so far away that if we sent a signal toward them today, it would never reach them. They are visible, but unreachable. We are watching the light of the past from places we can no longer touch, ghosts of a cosmos that has already slipped beyond our grasp. And with each passing billion years, more of the universe crosses that quiet threshold. The galaxies we see today are, one by one, being carried beyond the point where we could ever reach them, and eventually, beyond the point where we can even see them. The cosmos is, in the slowest and most graceful way imaginable, closing around us, not collapsing, not ending, but withdrawing, each distant light receding, dimming, reddening, until at last it passes over the edge and is gone. This gives rise to one of the most haunting visions in all of science, a vision of the far future, so lonely that it is almost unbearable to contemplate, and yet so beautiful in its way that it deserves to be seen. Picture a time, not billions, but trillions of years from now. The expansion has continued, accelerating all the while. One by one, the distant galaxies have crossed the event horizon and vanished from view. The great cosmic web, the sprawling architecture of clusters and filaments that fills the sky today, has been carried away into the unreachable dark. And the beings who might live in that distant epoch, if any beings live at all, will look up into their night sky and see only their own galaxy, or the small huddle of galaxies bound closely enough by gravity to resist the expansion, floating alone in a vast and perfect blackness, with nothing beyond. To such observers, the universe would appear to be a single island of stars, adrift in an empty void. They would have no way of knowing about the trillions of other galaxies that once filled the sky, for the light of those galaxies would have long since passed beyond their horizon. They would have no way of seeing the ancient glow of the cosmic microwave background, for it too would have been stretched and dimmed beyond all detection. They would have no way of measuring the expansion of the universe, for there would be no distant galaxies left to watch receding. The very evidence that revealed to us the true nature of the cosmos, the redshift, the ancient light, the expansion itself, would all be gone, erased not by any catastrophe, but simply by the passage of time and the quiet growth of space. And so those future thinkers, however wise, however capable, might well conclude that the universe was small and static and eternal, a single galaxy surrounded by endless emptiness, with no beginning and no expansion and no vast community of galaxies beyond. They would be wrong, but they would have no way to know it. The truth would lie forever beyond their reach, sealed away behind a horizon that had closed while they were not yet born. It is a strange and sobering thought that we may be living in a privileged moment in cosmic history, an age when the universe is still young enough, still open enough, that its deepest truths remain visible to anyone patient enough to look. Give it enough time, and those truths will fade, and the cosmos will forget, in a sense, what it once was. Which raises a quiet and unsettling question about ourselves. If future observers will be blind to truths we can plainly see, then might we too be blind to truths that earlier observers could once have seen, truths already carried beyond our horizon before we ever arrived to look for them? Almost certainly, yes. There is information the universe once offered that is now gone, sealed away before humanity existed. We see only what remains, a partial record, a fading photograph of a cosmos already larger and stranger than the fragment left to us. We are, all of us, latecomers to a story, most of which has already slipped past the edge of the seeable. But let us not sink too deep into that loneliness, for the story is not only one of loss, it is also one of astonishing possibility. And to feel that possibility, we must turn once more to the darkness beyond the edge, and to the boldest ideas about what might lie there. We spoke earlier of inflation, the theory that in the first sliver of a second, the universe underwent a burst of expansion so vast that it flung most of the cosmos forever beyond our sight. If that idea is correct, and much evidence suggests it is, then it carries a further implication that is nothing short of staggering. For according to many versions of the theory, inflation may not have happened only once, and it may not have stopped everywhere at the same time. In some regions, the theory suggests, inflation may go on forever, an eternal, ceaseless expansion, spawning region after region of space, each one blossoming outward, and within that endless froth of inflating space, pockets may form, where inflation ends, where the wild expansion settles down, where a universe like ours can take shape and cool and fill with stars. If this is so, then our entire observable universe, and all the unobservable universe beyond it, might be only a single bubble, one pocket among countless others, floating in a vaster sea of eternally inflating space. Each bubble would be its own universe, its own cosmos, perhaps with its own laws, its own kinds of matter, its own histories unfolding in isolation, sealed off from all the others by oceans of inflating space that no signal could ever cross. And there might be an endless number of them, forever being born, forever expanding, a multiverse of universes beyond counting, of which ours is but one quiet grain. We must be careful here, and honest, for this is the most speculative ground we will tread tonight. The multiverse is not established fact. It is a possibility, an implication of certain theories, a shadow cast by ideas we cannot yet fully test. We cannot see other bubble universes. We cannot reach them, or detect them, or prove they exist. By their very nature, they lie even further beyond our horizon than the unobservable regions of our own universe, sealed away by a double darkness. And yet the possibility follows so naturally from ideas we have good reason to take seriously that we cannot simply dismiss it. It hangs there at the very furthest edge of thought, a question we may never answer but cannot quite let go of. And so, When we ask what lies beyond the edge of the observable universe, we find the answer receding endlessly before us, like that horizon on the ocean. Beyond the edge lies more of our universe, unseen, but probably much like our own. Beyond that, perhaps, lie regions shaped by inflation, flung so far that their light will never come. And beyond even that, perhaps, lie other universes entirely, other bubbles in an eternal foam, each one a cosmos unto itself, layer upon layer of the hidden, each one more remote than the last, each one sealed away by a deeper and more absolute darkness. The edge we can see is only the first of many, the nearest shore of an ocean whose far side we cannot even imagine. There is a temptation, when faced with all this, to feel small, and it is a fair feeling, and there is no shame in it. Against the scale of the observable universe, the earth is a mote of dust, and the whole of human history is briefer than a blink. Against the scale of the possibly infinite universe beyond, or the possibly endless multiverse beyond that, even the words small and brief lose all meaning, for there is no comparison vast enough to make. We are tiny beyond tininess, fleeting beyond fleetingness, a single quiet awareness resting in a single quiet room on a single quiet world, surrounded by an immensity that does not know we exist. And yet there is another way to feel it, and it is just as true, for here is the wonder that redeems the smallness. That single quiet awareness, resting in that single quiet room, has somehow managed to work all of this out. A creature made of the same atoms as the dust and the stars, living for the briefest flicker of cosmic time, confined to a single small planet, unable to travel even to the nearest star, has nonetheless reached out with its mind and measured the age of the universe, mapped the ancient light of its first moment, weighed the galaxies, traced the expansion, and glimpsed the edge of the seeable itself. We cannot go to the edge of the observable universe, but we have found it, we have understood it, we have held it, in some sense, within the small, warm space of a human mind. And that, against all the odds, is not small at all. Let us ask, then, a question that children ask, and that scientists have never fully stopped asking. Could we ever go there? Could we ever travel to the edge of the observable universe and see for ourselves what waits at the boundary of the seeable? It is a beautiful question, and the answer, though it is no, is far more interesting than a simple refusal. To begin with, the distances alone defeat us utterly. The nearest star to our own sun lies more than 4 light-years away, a distance so great that our fastest spacecraft, hurtling along at speeds that would carry them around the Earth in minutes, would still take tens of thousands of years to reach it. And that is the nearest star, a next-door neighbor in cosmic terms. The nearest large galaxy is 2.5 million light-years away. The edge of the observable universe is more than 46 billion light-years away. To speak of traveling there is to speak of a journey so long that the numbers cease to mean anything at all. If you could somehow move at the speed of light itself, which nothing made of matter can, the journey would still take tens of billions of years, longer than the universe has yet existed. But the true impossibility runs deeper than mere distance, and it is here that the story becomes strange and wonderful. For the edge is not standing still, waiting for us to arrive. It is receding. The expansion of space is carrying it away from us, and beyond a certain distance, carrying it away faster than light. So even if you set out at the greatest speed the universe allows, you could never catch up to the most distant regions we can see. The space between you and them would grow faster than you could ever cross it. You would chase the edge forever and never reach it, like running toward a horizon that flees from you at every step. The furthest galaxies we observe tonight are already unreachable, sealed away not by distance, but by the geometry of a growing cosmos. We are watching their ancient light, but we could never, ever go to them. And suppose, for the sake of the dream, that you could. Suppose you were granted some impossible power, and you traveled outward, across the galaxies, across the billions of light years, all the way to the place where our horizon now lies. What would you find when you arrived? Would there be a wall, a boundary, a great glowing shell marking the end of everything? No, you would find nothing of the kind. You would find, to your astonishment perhaps, an ordinary region of space, much like the one you left. Galaxies would surround you, scattered across the darkness, spinning and shining, going about their slow cosmic business. There would be no edge, no boundary, no sign that you had arrived anywhere special at all. And when you looked around, you would find yourself, once again, at the center of a horizon. Your own horizon, a new sphere of the seeable, drawn around your new position, reaching out just as far as ever into the dark. And beyond it, galaxies you could not see, including, most likely, the Earth itself, now far beyond your reach, its light no longer able to cross the widening gulf to find you. This is the deepest truth about the edge, and it is worth resting on gently, for it dissolves the very idea of an edge into something far more subtle. The observable universe has no center and no boundary, or rather, every point is a center, and there is no boundary anywhere. The horizon is not out there, waiting to be reached. It is a relationship between you and the cosmos, a limit created by your particular place in space and time. Move, and it moves with you. It belongs to you, the way your shadow belongs to you, always near, always the same distance, never something you can step onto or leave behind. People often struggle with this, and no wonder, for our minds are built to imagine edges, walls, containers, things with an inside and an outside. When we hear that the universe is expanding, we want to ask, expanding into what? When we hear it has an edge we can see, we want to ask, what is on the other side of the wall? But the universe is not a thing inside a larger space. It is not a balloon inflating inside a room. It is the room and the space and everything, all at once, and there is no outside for it to sit within. The old image of raisins in rising bread helps a little. As the dough rises, every raisin drifts away from every other raisin, and from the point of view of any single raisin, all the others appear to be fleeing outward, with the most distant ones fleeing fastest. No raisin is at the center. Each one sees itself as the still point around which all the others recede. That is our situation exactly. Every galaxy sees all the others rushing away. Every galaxy could believe itself the center, and none of them is, because there is no center to be found. The expansion happens everywhere, all at once, with no special place where it begins. Another image, perhaps gentler still, is the surface of a balloon being slowly inflated. Imagine dots painted on the balloon's skin, each dot a galaxy. As the balloon swells, every dot moves away from every other dot, the surface itself stretching between them. And notice, there is no edge to the surface of a balloon. You could travel across it forever, around and around, and never come to a boundary, never fall off. Yet the surface is finite. It has a definite size. It curves back on itself, a finite space with no edge, expanding without expanding into anything, for the surface is all there is. Our universe may be something like that, though in more dimensions than we can picture, a space that is either endless or finite, but unbounded, growing without growing into anything, with no center and no rim. These are hard pictures to hold, and if they slip away from you as you rest, that is perfectly all right. The mind is not built for this, and there is no shame in feeling the strangeness of it. Even those who study these things for a lifetime confess that they cannot truly visualize an expanding, edgeless, possibly infinite universe. They work with equations, with mathematics that captures what the imagination cannot. And perhaps that too is part of the wonder, that reality can be stranger than anything we are able to picture, and yet we can still, through patience and care, come to understand it. It is worth remembering how recently we came to understand any of this at all. For nearly the whole of human history, no one knew. The edge of the observable universe, the expansion of space, the ancient light, the accelerating cosmos, all of it was utterly unknown just a few generations ago. The great discoveries that revealed the shape of everything are younger than some of the trees still standing in the world's old forests. For most of history, people believed the stars were fixed to a great crystalline sphere, not far above the earth, unchanging and eternal. Slowly, painstakingly, that picture was dismantled. It was learned that the stars were suns, immense and distant. It was learned that the faint band of light across the night sky, the Milky Way, was made of countless stars too far away to see individually. And for a long time, it was believed that the Milky Way was the whole of the universe, an island of stars surrounded by infinite empty darkness with nothing beyond. Then, less than 100 years ago, that belief too was overturned. Astronomers found that certain faint smudges in the sky, long thought to be clouds of gas within our own galaxy, were in fact other galaxies, impossibly distant, each one a vast collection of billions of stars, as large as the Milky Way or larger. In a single stroke, the known universe expanded 1,000,000-fold. Ours was not the only galaxy. It was one among a great multitude, scattered across a cosmos far larger than anyone had dreamed. And soon after came the discovery that changed everything. The realization that those distant galaxies were not sitting still, but rushing away, their light reddened by the stretching of space. This was the moment humanity first understood that the universe was expanding, that it had a history, that it was growing and changing through time. And if it was expanding now, it had been smaller before, which meant it had a beginning, a first moment, a birth. The idea was so radical that many resisted it, preferring to imagine an eternal, unchanging cosmos. But the evidence grew and grew until it could not be denied. The final and perhaps most beautiful confirmation came almost by accident. Two researchers, working with a large radio antenna, kept finding a persistent faint hiss in their instrument, a background noise coming from every direction of the sky that they could not explain or eliminate. They checked their equipment, they cleaned it, they even cleared away the droppings of pigeons that had nested inside the antenna, suspecting the mess might be the source of the interference. But the hiss remained, steady, uniform, coming from everywhere at once, and eventually they realized, with the help of others, what they had stumbled upon. It was the cosmic microwave background, the ancient light of the young universe, the afterglow of the beginning, filling all of space. They had found, quite by chance, the oldest light in creation, the wall at the edge of the seeable. What had seemed like meaningless static was in truth a message from the dawn of time. There is something deeply moving in that story, and in all these stories, this slow, halting, human process of discovery. No single person understood the universe. It was worked out gradually, across generations, by countless minds building on the work of those before them, each adding a small piece, each seeing a little further, until at last the outline of the whole emerged. We did not inherit this knowledge. We earned it, painstakingly, over centuries of looking and wondering, and being wrong and trying again. And it is still unfinished. There are pieces we do not have. There are mysteries, like the nature of dark energy, that we have barely begun to touch. The picture of the universe you are hearing tonight is the best we have so far, but it is not the last word. It is a work in progress, a story still being written, at the very edge of what we know. How, then, do we actually see the edge? How do we look across billions of light years, across billions of years, to the faint and ancient light at the boundary of the observable universe? The answer lies in the great instruments we have built, the telescopes, which are, in a sense, time machines. For to gather light that has traveled for billions of years is to look directly into the deep past, and the larger and more sensitive the telescope, the further back in time it can see. There is a kind of quiet heroism in these instruments, and in the patience they demand. To see the most distant galaxies, a telescope must gather light so faint that only a handful of particles of it might arrive over the course of hours. It must hold perfectly still, staring at a single tiny patch of sky, collecting that trickle of ancient light drop by drop, hour after hour, sometimes for days on end, building up an image from a whisper. and the light it gathers has been stretched so severely by the expansion of the universe that it no longer arrives as visible light at all, but as infrared, as heat, its colors drawn out and reddened by the long journey across a growing cosmos. To see the young universe, we must look not for its light, but for the faint, warm ghost of its light, stretched almost beyond recognition. One of the most extraordinary things we have ever done with these instruments is also one of the simplest to describe. Astronomers chose a patch of sky that appeared to be utterly empty, a small, dark square containing no visible stars, no galaxies, nothing at all, a piece of the heavens so unremarkable that it seemed a waste to point a great telescope at it. And then they pointed the telescope at it anyway and left it there, staring into that darkness, gathering light for days. And when the image was finally revealed, that empty patch of blackness was not empty at all. It was filled, edge to edge, with galaxies, thousands of them, great spirals and glowing ellipticals and strange young shapeless things, some of them so distant that their light had traveled for well over 13 billion years to reach the telescope, in a scrap of sky so small you could blot it out with a grain of sand held at arm's length. There were thousands upon thousands of galaxies, each one home to billions of stars. Sit with that image for a moment, in the dark, before you sleep. Every direction you could point a telescope, no matter how empty it looks, is like that, filled with galaxies, layered back through time, all the way to the edge. The apparent emptiness of the night sky is an illusion, a limitation of our eyes. The truth is that the universe is crowded with light, drenched in it, from the nearest planet to the furthest wall of ancient fire. We simply cannot see most of it without the great patient eyes we have built. But it is there. It has always been there. A cosmos brimming with galaxies, reaching outward in every direction, further than the mind can follow, all the way to the horizon and the wall of light beyond which we cannot pass. And when we gather that light and study it, we can read in it the whole history of the universe, laid out like the rings of a tree. The nearby galaxies show us the cosmos as it is now, mature and settled. Further out, we see galaxies as they were billions of years ago, more chaotic, more actively forming stars, still coming together. Further still, we see the first galaxies, small and irregular, taking shape in the early darkness. And beyond even them, past the last of the galaxies, we reach the wall of light, the cosmic microwave background, the glow of the universe before any star had formed, when all was fog and fire. To look outward is to watch the entire story of creation unfold in reverse, from the settled present all the way back toward the blazing beginning. There is a period, though, that even our greatest instruments have struggled to see, a stretch of cosmic history that has earned a fitting and evocative name: the Cosmic Dark Ages. It lies just beyond the wall of light, in the long stretch of time after the fog lifted but before the first stars ignited. In that era, the universe was transparent at last, but there was nothing yet to shine. The atoms had formed, the light had been set free, but the first stars had not yet been born. Space was filled with vast cold clouds of hydrogen and helium, drifting in darkness, waiting. There was no light being made anywhere in the cosmos, only the fading afterglow of the beginning, growing dimmer as the universe expanded. For millions of years, the universe was truly dark, a lightless expanse of gas, silent and patient, holding within it the seeds of everything that would come. And then, slowly, gravity did its quiet work. In the densest regions, the clouds of gas began to draw together, pulled inward by their own weight, growing denser and hotter as they collapsed, until at their cores, the pressure and the heat crossed a threshold, and the first stars flared into being. The cosmic dawn. After ages of darkness, light returned to the universe. Not the ancient afterglow of the beginning, but new light, starlight, made in the hearts of the very first stars. And from those first stars came the first heavy elements, forged in their cores and scattered into space when they died, the raw material from which later stars and planets and eventually life itself would be made. Every atom in your body, heavier than hydrogen, was made inside a star, cooked in stellar fire, and cast out into space to be gathered up again. You are, quite literally, made of the ashes of ancient stars, assembled from the dust of a cosmos that had to live and die many times over to produce the elements that make you. We are only beginning to glimpse that cosmic dawn, that first flowering of light after the Dark Ages. It lies at the very frontier of what our instruments can reach, and each new telescope pushes a little deeper toward it, catching the faint red glow of the earliest stars and galaxies as they first switched on. It is one of the great quests of our age, to see that first light, to witness the moment the darkness ended, and it sits, fittingly, right at the edge of the seeable, in the shadowy borderland between the wall of light and the first stars, at the very boundary of the observable universe. But now let us turn from the beginning toward the end, from the edge in the past toward the edge in the future. For the story of the observable universe is not only a story of how far we can see, but of what will become of everything we see. And here the accelerating expansion, the dark energy that pushes the cosmos apart, writes the final and longest chapter of all. We have spoken of how, in the far future, the distant galaxies will one by one cross the horizon and vanish from sight, leaving whatever observers remain adrift in an apparently empty void with only their own island of stars for company. But that is only the beginning of the long ending. For as the eons stretch on, trillions upon trillions of years, the universe will continue to change, slowly, inexorably, cooling and dimming and winding down toward a final quiet state from which it will never emerge. The stars, for all their apparent permanence, are not eternal. Each one burns through its fuel and dies, some in violent explosions, some in a slow guttering fade. New stars are born from the gas and dust left behind, but the supply of fresh gas is not infinite. With each generation of stars, a little more of the universe's raw material is locked away in dead stellar remnants, in cold cinders and collapsed cores, and a little less remains to form new stars. And so, over vast stretches of time, the rate of star formation will slow, and slow, and slow, until at last the final stars are born, burn, and die, and no new ones ever take their place. Imagine that distant epoch, when the last star in the universe flickers out. After that, there will be no more starlight anywhere in the cosmos. The galaxies, or what remains of them, will be filled with the dark and cooling husks of dead stars, drifting in an endless night. The universe will grow darker and colder, lit only by the faint, fading glow of stellar corpses, and then, eventually, not even by those. The long twilight will deepen toward a darkness more complete than any the universe has ever known, a darkness with no dawn to follow it. And still time will stretch on, far beyond even that. The dead stars will drift, the galaxies will slowly come apart, and over timescales so vast that the numbers lose all meaning, even matter itself may not endure forever. The universe will continue to expand, to cool, to spread its dwindling energy ever more thinly across ever greater volumes of space, approaching, over the unimaginable ages, a state of perfect cold and perfect stillness, in which nothing happens, nothing changes, and nothing ever will again. Scientists have a name for this final state, sober and quiet. They call it the heat death of the universe, though it is really a cold death, an ending not of fire, but of frost. A cosmos spread so thin and grown so cold that it settles into an eternal, changeless rest. It is, perhaps, the loneliest thought in all of science, this vision of the ultimate end. And yet, I would ask you not to let it frighten you as you drift toward sleep, but to hold it gently, the way you might hold any distant and inevitable thing. For that ending lies so unfathomably far in the future that it barely deserves to be called future at all. The timescales involved dwarf the current age of the universe as thoroughly as the age of the universe dwarfs a single heartbeat. Between now and then lie ages upon ages in which stars will shine, and worlds will form, and perhaps life will arise and flourish and wonder, over and over, across the vast reaches of cosmic time. The ending is real, but it is so distant that the space between here and there is filled with almost limitless possibility. We live near the bright beginning of a very, very long story, in an age of light and warmth and stars, and there is no need to grieve an ending so far removed that it is closer to a mathematical truth than to anything we could ever witness or feel. There is a question about darkness that seems, at first, almost too simple to ask, and yet it turns out to hold within it one of the quietest proofs of everything we have been saying. The question is this: why is the night sky dark? It sounds like a child's question, and perhaps it is, but sit with it for a moment and it becomes strange. If the universe is truly vast, filled with a great multitude of stars, then imagine looking out in any direction at all. If the stars go on far enough, in enough numbers, then no matter which way you looked, your line of sight should eventually land on the surface of a star. Every point in the sky should be filled with starlight. The whole sky, in every direction, should blaze as bright as the surface of the sun, a wall of light with no darkness anywhere between the stars. And yet, when you look up at night, you see mostly darkness, a black sky, scattered with only a relatively few points of light. Why? In a universe full of stars, why is the night dark at all? This puzzle troubled thinkers for a very long time, and its answer, when it finally came, was profound. The night sky is dark because the universe is not infinitely old, and because we can only see so far. If the universe had existed forever, and if it stretched infinitely in every direction, and if the light from every star had had endless time to reach us, then indeed the whole sky might blaze. But that is not our universe. Our universe had a beginning, only about 13.8 billion years ago, and light travels at a finite speed, and so we can only see the stars whose light has had time to arrive. Beyond the edge, beyond the horizon we have journeyed toward all night, there may be countless more stars, but their light has not reached us, and much of it never will. The darkness between the stars is, in a sense, the darkness beyond the edge showing through. It is the unlit gaps where the light has not yet come, or can never come. Think of what that means. The very darkness of the night sky, the gentle blackness that lets the stars stand out, that makes the night restful rather than blinding, is itself a consequence of the finite age of the universe and the existence of the cosmic horizon. Every time you have ever looked up at a dark night sky, you have been looking at evidence, quiet and unremarked, that the universe had a beginning and that the seeable has an edge. The darkness is not empty, it is not nothing. It is the signature of a young cosmos with a boundary to its light. The night is dark because the universe is not old enough and not visible enough to fill it with fire. And there is a further layer to this, one we have already touched, but that deserves to be seen again in this light. The darkness between the stars is not truly empty even of ancient light. If your eyes could see in microwaves, if you could perceive the stretched and cooled radiation that fills all of space, then the entire sky, in every direction, including the darkest gaps between the stars, would glow. For behind the stars, behind the galaxies, at the very edge of the seeable, lies the wall of light, the cosmic microwave background, the afterglow of the beginning. It fills the whole sky. There is no truly dark direction. Every line of sight, if followed far enough, does end at a wall of light after all. Not the surface of a star, but the surface of last scattering, the glowing shell of the infant universe. It is only that this light has been stretched so far, cooled so deeply by the expansion of the cosmos, that our eyes cannot see it, and so the sky appears dark. The blaze is there. It has simply been dimmed by billions of years of expansion into a whisper only our instruments can hear. So the answer to the child's question turns out to contain the whole of tonight's story. Why is the night sky dark? Because the universe is young and finite in the seeing, with an edge beyond which the light has not come, and because the light that does fill every direction, the ancient glow of the beginning, has been stretched by the growth of space into something too faint and too cold for human eyes. The darkness is the edge, and the beginning, and the expansion, all written quietly into the emptiness above us, waiting there for anyone who thinks to ask why the night is not on fire. Now, we have said many times that the wall of light is the furthest we can see, that the fog of the early universe hides everything before the moment the atoms formed, and that light cannot carry us past that curtain. And with light, that is true. But light is not the only messenger the universe sends. And in recent years, we have begun, very tentatively, to reach for other messengers, other ways of listening to the cosmos, that might one day let us peer even past the wall of light into the hidden ages before. Consider first a ghostly particle called the neutrino. Neutrinos are among the strangest things in nature. They are almost nothing at all, so light and so reluctant to interact with ordinary matter that they pass through everything as though it were not there. As you rest, uncountable trillions of neutrinos are streaming through your body every second, through the earth beneath you, through the whole planet, as if it were empty glass, and you feel nothing, and they are gone. Because neutrinos interact so weakly, they can travel through material that would stop light completely. And this means that neutrinos could, in principle, have escaped from the early universe far earlier than light did, from a time long before the fog lifted, when the cosmos was still opaque to every ray. There should exist, filling all of space, a background of ancient neutrinos, released in the universe's first seconds, carrying an image of an era light can never show us. We have not yet managed to detect that primordial neutrino sea directly, for the very quality that let the neutrinos escape, their ghostliness, also makes them maddeningly hard to catch. But it is out there, in principle, a hidden message from a time before the wall of light, waiting for us to grow clever enough to read it. And consider something stranger still, a messenger not of particles but of space itself. When massive objects move violently, when black holes collide, or stars explode, or the fabric of the cosmos convulses, they send out ripples, waves that travel through the very geometry of space, stretching and squeezing everything they pass, ever so slightly, as they go. We call them gravitational waves, and for a long time they were only a prediction, a consequence of our theories that no one had ever observed. But we have now, at last, begun to detect them, using instruments so exquisitely sensitive that they can measure a change in length smaller than the width of an atomic nucleus, the faint stretching of space as a gravitational wave rolls through the Earth. And here is the wonder. Gravitational waves, like neutrinos, can pass through the early cosmos unimpeded. They were not trapped by the fog. If the universe's first violent instance, the very moment of inflation itself, sent out gravitational waves, as many theories suggest they must have, then those primordial ripples are still washing through the cosmos today, carrying within them an image of the first fraction of the first second, from before the wall of light, from a time utterly beyond the reach of any telescope. To detect them would be to hear the faint echo of the beginning itself, the universe's very first cry, preserved in the trembling of space. We have not heard that cry yet. It is faint, and buried beneath the noise of a loud and busy cosmos, and detecting it may take generations of ever more delicate instruments. But the possibility is there, and it is breathtaking. It means the wall of light may not be the final curtain after all. It means there may be ways to reach behind it, to sense the hidden ages before the fog lifted, not with light, but with ghost particles and ripples in space. The edge in time, like the edge in space, may prove to have a little more beyond it that we can touch, if only we learn how to listen. The universe, it seems, keeps more than one door, and though light can open only one of them, there may be others, waiting, for a species patient and clever enough to find the handles in the dark. It is worth pausing, too, on the word we have used so often tonight, the word horizon, for it turns out that the cosmic horizon is not the only horizon in nature, and its cousins can help us feel what it truly is. The most famous of these cousins lives at the heart of a black hole. A black hole is a place where matter has collapsed so completely, grown so dense, that its gravity becomes overwhelming, bending space so severely that beyond a certain boundary nothing can escape, not even light. That boundary is called the event horizon, and it is, in its own way, deeply similar to the horizon of the observable universe. Cross the event horizon of a black hole, and you can never send a signal back out. The light you emit can never climb free of the gravity. To anyone outside, you would simply vanish, your final image frozen and reddened at the boundary, fading forever. Within the black hole lies a region sealed off from the rest of the universe, a place from which no message can ever return, hidden behind a horizon woven from gravity and the bending of space. The cosmic horizon is much the same, only turned inside out. With a black hole, the sealed-off region is inside the horizon, small and dense and inescapable. With the observable universe, the sealed-off region is outside our horizon, vast and growing and unreachable. But the essence is identical. Both are boundaries beyond which no signal can pass, edges of the knowable drawn by the geometry of space itself, and both remind us of the same humbling truth, that the universe is full of horizons, full of places sealed away from one another, full of edges beyond which even light cannot carry a message. We are surrounded by such boundaries, near and far, from the tiny dark hearts of collapsed stars to the great sphere that bounds all we can see. Reality is not one seamless, fully connected whole. It is divided, partitioned, sealed into regions by the limits of light and gravity and time, each one holding secrets the others can never learn. And even our own galaxy is drifting, sealed for now within its own small pocket of the connected cosmos, being carried through the vast web of matter that structures the universe on the largest scales. For the galaxies are not scattered evenly through space. They are strung together into a great cosmic web, immense filaments of galaxies stretching across hundreds of millions of light years, threaded around enormous empty voids, the whole universe resembling, on the grandest scale, something like a vast three-dimensional network of light and shadow, of dense bright strands and hollow dark spaces. Our own galaxy sits within this web, part of a small cluster, drawn slowly through space toward regions of greater density, pulled by the gravity of distant, immense concentrations of matter whose full extent we are still mapping. We are moving, all of us, carried along on this small world, on this drifting galaxy, through the great web of the cosmos, at speeds of hundreds of kilometers every second, and we feel none of it, for there is nothing to feel it against, only the silent stars and the ancient light and the slow unfolding of the universe around us. Let us take that motion, that quiet drifting through the cosmos, and make a journey of it. Let us travel outward together, slowly, from where you are resting all the way to the edge of the seeable, pausing at each threshold, feeling the distances open beneath us, like the floors of a great tower falling away. There is nothing to do but follow and drift and let the scale unfold. Begin here, in this room, in this quiet moment. Feel the solid earth beneath you, the whole broad turning world, holding you gently as it always has. Now rise, in your mind, softly upward, until the room falls away below, and the roof, and the streets, and the town, all growing small, until you can see the land curving beneath you, the patchwork of fields and forests and water, the lights of the cities glittering in the dark like fallen constellations. Rise higher, and the whole earth gathers itself into a sphere, blue and white, wrapped in its thin, bright skin of air, turning slowly in the black, the only world we have ever known, the only home, holding every person who has ever lived within its small curved surface. Rise higher still, and the earth shrinks to a point, a pale blue dot adrift in the dark, and the moon drifts near it, gray and silent, 250,000 miles away, the furthest any human has ever traveled. Feel how far that is, and how small it is, against what is still to come. Now the sun swells before us, vast and golden. 1,000,000 Earths could fit inside it, pouring out its light in every direction, and the planets wheel around it in their great slow orbits, the small rocky worlds near in, the giant worlds of gas and ice far out, and beyond them a shell of frozen debris, and then the edge of the sun's domain, where its light grows thin and its influence fades into the dark between the stars. Keep rising. The whole solar system, the sun and all its worlds, contracts to a single bright point behind us, and around us now the true dark opens, the space between the stars, so empty and so wide that our fastest craft would take tens of thousands of years to cross even to the nearest neighbor. And there the neighbor is, another sun, and another beyond it, and another, until the stars gather thick around us, thousands, then millions, then billions, and we see that we are inside something, a great flattened wheel of stars turning slowly in the void, and we rise up out of its plane to look back, and there it is below us, the Milky Way, our galaxy, a luminous spiral of hundreds of billions of suns, so wide that light takes 100,000 years to cross it, and our own sun, with all its worlds, is a single, unremarkable speck somewhere out along one of its curving arms, unnoticed, unmarked, one grain of light among the uncountable grains. Do not stop yet. Rise further, and the whole galaxy, that vast wheel of 100 billion suns, shrinks to a glowing pinwheel, and we see that it too is not alone. Nearby floats another great spiral, Andromeda, drifting toward us across the millions of light years, and scattered around them a handful of smaller galaxies, a little family bound together by gravity, our local group, drifting through the dark. And that little family is itself only a small knot in something larger, for as we rise higher the galaxies multiply around us, gathering into clusters, hundreds and thousands of galaxies bound together, and the clusters gather into superclusters, and the superclusters string themselves into the great filaments of the cosmic web, immense bright threads of galaxies stretched across the darkness, woven around vast hollow voids where almost nothing lies at all. The universe, seen from far enough away, looks almost alive, a great branching network of light and shadow, of dense glowing strands and empty dark spaces, more like something grown than something built. And still we are not near the edge. Keep rising, keep drifting outward through the web, past filament after filament, cluster after cluster, galaxy after galaxy, each one holding its hundreds of billions of stars, each star perhaps holding worlds, each world perhaps holding, who knows, some quiet history of its own. The numbers climb past all meaning, 1,000 galaxies, 1,000,000, 1,000,000,000, and on, until we approach the great sphere that bounds it all, the edge of the seeable, 46 billion light-years from where we began, in a room, on a small blue world, only moments ago. And as we near that edge, something changes in the light. The galaxies here are younger, stranger, still forming, for we are seeing them as they were billions of years ago, in the early ages of the cosmos. And then, past the last of the galaxies, we come to it at last, the wall of light, the surface of last scattering, the glowing shell of the infant universe, the afterglow of the beginning, filling the whole of the sky around us. This is the edge. This is as far as sight can reach. Beyond it lies the fog, and the first ages, and the hidden beginning, and beyond that, perhaps, more universe without end, forever sealed away. We have traveled as far as it is possible to travel, all the way from a quiet room to the boundary of everything, and here we must stop, for there is nowhere further to go. And now, from this furthest place, turn around and look back. Look back across the whole of it, the wall of light, the young galaxies, the great cosmic web, the clusters and the superclusters, the local group, the Milky Way, the sun, the small pale earth, the room, the quiet moment, you, resting, at the center of all of it. For that is the strangest and most beautiful part of the whole journey. No matter how far we traveled, we never left the center. You are still at the center of your own observable universe, as you always were, as you always will be, the still point around which the entire seeable cosmos is gathered. The edge is 46 billion light-years away in every direction, and you are exactly in the middle, not because you are important, but because that is simply what it means to look out upon the universe from where you are. The whole vast sphere, 93 billion light-years wide, 2 trillion galaxies, uncountable stars, all of it arranged around this single point, this single quiet awareness, resting here, now, at the heart of everything it can see. Let that settle over you like a warm and heavy blanket. You have journeyed to the edge of the universe and back again, and found that you never left the center, and that the center is here, where you are, where it has been all along. There is nowhere you need to go to find the wonder. It surrounds you already. It has always surrounded you. Every direction you could ever look is filled, layer upon layer, with galaxies and ancient light and deep time, reaching outward to a horizon that belongs to you alone. You are not lost in the universe. You are the place where a small piece of the universe has gathered itself together and begun, quietly, to look around. There is a subtlety hidden inside everything we have been saying, a strange and quiet truth about time and light that is worth drawing out slowly, for it changes the way you see the night sky forever. When you look out into the universe, you never see anything as it is now. You only ever see the past. The further away a thing is, the older the image you receive. And this means that the observable universe is not a snapshot of the cosmos at a single moment, but a layered vision, each shell of distance showing a different age, all of it arriving at once, all of it woven together into the single sky you see. Consider what this means. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest stars, you see them as they were years ago. When you look at the heart of our own galaxy, you see it as it was tens of thousands of years ago, when the last ice age still gripped the Earth. When you look at the Andromeda galaxy, you see it as it was 2.5 million years ago, before your species existed. And when you look at the wall of light at the edge of everything, you see the universe as it was more than 13 billion years ago, in its very infancy. All of these images arrive together, in the same instant, filling the same sky. The night sky is not a picture of the universe now. It is a picture of the universe's entire history, arranged by distance, each layer a different depth of time. This has a consequence so strange that it barely fits inside ordinary language. There is no single, shared now that stretches across the universe. When you wonder what a distant galaxy is doing right now, at this very moment, as you rest, the honest answer is that the question does not quite have a meaning. You cannot see its now. You can only ever see its past. And by the time any signal could cross the vast distance between you, the moment you were curious about would be ancient history. In a very real sense, the distant reaches of the universe do not share a present with us at all. Each region drifts in its own flow of time, connected to us only by the slow crawl of light across the gulf. We are joined to the cosmos, not in the present, but through the past, through the ancient messages that light carries across the dark. And so the edge of the observable universe is, in the most literal way, the edge of the past that we can touch. It is the furthest back in time we can see, the earliest moment whose light has reached us. To gaze at it is to gaze at the beginning, or as near to the beginning as light will allow. And every night, without knowing it, when people glance up at the stars, they are looking backward through time, seeing a universe that in many places no longer exists as it appears. Its stars long since changed, some of them long since dead, their light still traveling, still arriving, still faithfully carrying an image of a moment that has already passed. The night sky is a kind of memory, the universe remembering itself, showing us not what is, but what was, all the way back to the first light of creation. Let us try, gently, to feel the scale of it, though we will surely fail, for the scale is beyond feeling. But there is value in the trying, and it can be a soothing thing, to let the mind stretch toward the vast until it grows pleasantly tired. Begin with the earth beneath you, this world that feels so large, whose oceans take days to cross, and whose distant places feel impossibly far. Now hold in your mind that the Earth is a single small planet, orbiting a single ordinary star. That star, our Sun, is so large that more than 1,000,000 Earths could fit inside it. And yet it is an unremarkable star, middling in size, one of hundreds of billions in our galaxy. Picture those hundreds of billions of stars, each one a sun, many with their own worlds, spread across the great spiral wheel of the Milky Way, so wide that light itself, the fastest thing there is, takes 100,000 years to cross from one side to the other. Now pull back further. That entire galaxy, with its hundreds of billions of stars, is a single galaxy among a vast crowd. Within our observable universe, there are not hundreds, not thousands, not millions, but somewhere around 2 trillion galaxies, each one a sprawling island of stars, each one as rich and vast as our own, or richer. 2 trillion galaxies. If you tried to count them, one each second, without ever sleeping or pausing, you would not finish in 100 lifetimes. And each of those galaxies holds its own hundreds of billions of stars, so that the total number of stars in the observable universe is a number so large it has no meaning to us, a number greater than all the grains of sand on all the beaches of the earth, greater by far, uncountable, unimaginable. And all of that, the 2 trillion galaxies, the uncountable stars, the endless worlds, fills a sphere 93 billion light-years across, and that sphere is only the part we can see. Beyond it lies more, unseen, perhaps without end. When you try to hold all of this in your mind at once, you will find that you cannot, and that is not a failure. It is the correct response. The universe is genuinely too large for a human mind to contain. All we can do is hold a small piece of it, a single true thought, and let that thought open outward toward the immensity, like a door left ajar onto a night too vast to enter. And here is the thought I would leave with you, as we begin, slowly, to draw this long journey toward its rest. Out of all that immensity, out of the 2 trillion galaxies and the uncountable stars, there is, as far as we know, one place where the universe has woken up and begun to look at itself. Here, on this small world, in minds like yours, you are made of the same atoms as the distant stars, forged in the same stellar fires, scattered by the same ancient explosions, gathered together over billions of years into something that can wonder. When you contemplate the edge of the observable universe, it is, in a strange and literal sense, the universe contemplating itself. The cosmos has, in you, grown a small window through which it can gaze back upon its own vastness and ask what it all means. That is not a small thing. In all the endless dark, it may be one of the rarest and most precious things there is. We do not know whether we are alone. In a universe this large, with so many stars and so many worlds, it seems almost impossible that life should have arisen only once, only here, and yet we have found no others, not yet. And the distances that separate us from any possible companions are so vast that we may never bridge them. Perhaps the cosmos is full of quiet minds, each one gazing up at its own horizon, each one wondering, each one alone within its own bubble of the seeable, all of us separated by gulfs of space and time, too wide to cross. Or perhaps we truly are alone, a single flicker of awareness in an unimaginable darkness. Either way, there is something both humbling and precious in the wondering itself, in the simple fact that anything anywhere is able to ask the question at all. And so we return, at the last, to the edge, and to what it means for us that it exists. It would be easy to feel a kind of sorrow at the edge of the observable universe, to feel it as a wall, a limit, a door closed against us. There is so much we cannot see, so much sealed away beyond the horizon, so much we will never reach and never know. The universe keeps its deepest secrets behind a boundary we cannot cross, and no matter how clever we become, no matter how powerful our instruments, that boundary will remain, dictated by the speed of light and the age of time and the relentless expansion of space. We are, in the end, confined to our own small bubble of the knowable, gazing out at a cosmos most of which we can never touch. But I would ask you to feel it differently, as you rest, to feel the edge not as a wall, but as a horizon. And a horizon is not a barrier. A horizon is an invitation. It is the promise that there is always more, always further, always something beyond the reach of what we currently know. A world without horizons would be a world fully mapped, fully known, with nothing left to discover, and how small and airless such a world would be. The edge of the observable universe is the guarantee that this will never happen to us, that no matter how much we learn, there will always be a further mystery, a deeper question, a darkness beyond the light that calls us onward. The edge does not close the universe. It opens it endlessly, keeping the great questions alive, keeping wonder possible, keeping us reaching. And there is a quiet peace to be found in accepting that some things are not meant to be fully known. We spend so much of our lives grasping, striving, trying to master, and to hold, and to understand. But the edge of the observable universe teaches a gentler lesson. It teaches that we can stand before something vastly greater than ourselves, something we will never conquer or contain, and instead of despairing, we can simply behold it. We can let it be vast. We can let it be mysterious. We can rest in the presence of the immense and the unknowable without needing to seize it. The way you might stand at the shore of a dark ocean at night, feeling its size, hearing its depth, and being content, for a while, simply to be small beside something so large. Perhaps that is the truest gift the edge of the universe offers, this permission to be small and to be at peace with it. We live in a time that prizes knowing, that treats every mystery as a problem to be solved, and every boundary as an obstacle to be crossed. And there is beauty in that hunger, in the long human effort to understand, which has carried us so far. From the first questions asked beneath the first dark skies, to the mapping of the ancient light at the edge of time. But there is beauty, too, in the opposite gesture, in laying the hunger down for a while, in standing before something we cannot grasp, and choosing not to grasp it, only to behold it. The edge of the observable universe cannot be crossed. It cannot be conquered. It will keep its secrets no matter how we strive. And instead of grieving that, we can rest in it, the way you rest at the end of a long day, letting go of all the things you cannot finish, all the questions you cannot answer, and simply being present with what is. For the mystery beyond the edge is not an enemy. It is not a locked door mocking us with what we cannot reach. It is more like the deep water beyond the shallows, the dark beyond the campfire, the silence beyond the last note of a song. It is the necessary background against which all our small, bright knowing takes its shape. Without the unknown, the known would have no edges, no contrast, no wonder. It is the vast, dark surround that makes the light precious. And so the unreachable universe beyond our horizon is not a loss. It is the very thing that keeps the cosmos endless, that keeps the wondering alive, that ensures there will always be more, always further, always a deeper night beyond the furthest star we have named. And there is a kind of companionship in it too, strange as that may sound. For every awareness anywhere in the cosmos, if there are others, faces the same edge. Each one sits at the center of its own sphere, bounded by the same speed of light, the same age of time, the same relentless expansion. Whatever beings may exist, on whatever distant worlds, beneath whatever alien skies, they can see no further than we can, in their own way. They too are held within a horizon. They too gaze out at a universe, most of which they can never touch. In that, at least, we are not alone. Even if we never meet them, we are joined to every possible mind across the whole of creation by this shared condition, this shared smallness before the immense, this shared standing at the center of a sphere we did not choose and cannot leave. And perhaps, in some quiet way, that is a kind of kinship, spread thin across the galaxies, a fellowship of all things that look up and wonder and cannot see the edge of everything, but reach toward it anyway. So as the night deepens around you, and the day's last thoughts grow soft and slow, Let the universe be exactly as vast and as mysterious as it is. You do not have to hold it. You do not have to solve it. You do not have to reach its edge tonight or any night. It is enough to know that it is there, all of it, the 2 trillion galaxies and the uncountable stars, and the ancient light still falling, and the horizon drawn silently around you, all of it turning gently through the dark, whether you watch or sleep. It asks nothing of you. It only surrounds you, patient and immense and quietly beautiful, the way it has surrounded every sleeping creature on this world since the first life stirred beneath the first stars. You have gone to the edge of everything tonight. You have stood at the wall of light and looked past it into the dark. You have felt the size of the cosmos and your own small precious place within it. And now there is nothing left to do but let it all grow dim and distant, the galaxies fading, the light softening, the great sphere of the seeable dissolving gently into the quiet of your own breathing, as you drift back down from the edge of the universe toward the near warm edge of sleep. And now there is nothing left to reach for. The journey is behind you, the whole long climb out to the edge and the slow drift home, and all of it can be set down now, the way you set down anything heavy at the end of a long day. You do not need to remember it. You do not need to hold a single fact or figure. Let them loosen their grip and float free, the numbers and the names, the galaxies and the ancient light, until only the feeling remains, soft and wordless, the quiet after wonder. Feel how still it is here. Out there, the universe goes on with its slow and patient work, stars kindling and fading, space widening by the smallest measure, the old light falling endlessly through the dark. None of it needs your attention tonight. It has kept itself for 13 billion years without your help, and it will keep itself through the hours of your sleep, turning gently, asking nothing, holding no expectation of you at all. You are allowed, for a while, to simply be held by it, the way a small boat is held by a wide and quiet sea. Let your breathing slow to match that stillness, each breath a little deeper, a little softer, in and out, like the long, slow rhythm of the cosmos itself, expanding and resting, expanding and resting. There is nowhere to go. There is nothing to finish. The edge of everything is still out there, exactly where it has always been, and it will wait, patient and unhurried, for as long as you need. It is not going anywhere, neither are you. And if a last image lingers as you drift, let it be a gentle one. Let it be that faint and ancient glow at the edge of the seeable, the first light of the beginning, still traveling after all this time, still arriving, quiet as snowfall, warm as memory. It has crossed the whole of the universe to be here, in this room, in this moment, with you. It asks for nothing. It only settles softly over everything, over the world and the dark and your slowing thoughts, a blanket woven from the oldest light there is. Rest now. You are a small, warm point of awareness beneath an immensity that means you no harm, and that is enough. It has always been enough. Let the edge grow distant. Let the stars grow dim. Let the great sphere of the seeable soften and blur and fade into the quiet of your own breathing. And let yourself, gently, at last, drift down from the edge of the universe into the near and welcome dark of sleep.